Hello and welcome to this session of Groundbreakers Live. I'm your host, Javed Mohammed, and I'm very honored to have with us a colleague and friend, Heli Helskyaho, whose name I will get one day very right. Hello, Heli, welcome.
Hi, thank you.
So Heli is an author, CEO of Miracle Finland, as well as an Oracle ACE director, and I'm sure she's got a lot more credentials, but than we have time for. But Heli, it's always great to see you.
Likewise.
All right. So you were going to be presenting at Dev.next. I think your title there was going to be Introduction to Deep Learning. So I guess we normally hear about machine learning, but I guess you've taken a slightly different angle of, and I'm sure they're interrelated. So talk to us about deep learning. You know, where is it used? Why? You know, how?
Yeah.
I'll ask all these
So,
questions up front.
so a lot of people are talking about deep learning because there are so many fantastic use cases for that. Like one example is image recognition, and for medical purposes. So if you have pictures like I have to take notes now because I can't remember what they are in English. So I have notes here. So like if you have ultrasound, X-ray, computer tomography scans, magnetic resonance imaging, position imaging tomographies, PETs, retinal photography, histologists, and demography images. I can't even pronounce these names, but I'm sure the medical people do understand. You can use a machine learning to recognize, let's say, a tumor. So just showing those pictures to computer, you will know if the person has a tumor or not. And funnily enough, computers are even better than doctors, an average doctor, to know if this person is sick or not. So a doctor might say there's nothing in the picture, but the computer will say there's something wrong. And what makes it interesting using deep learning is that you can actually build models pretty well without understanding medical area so much. So you can build models relying on the computer. Of course, whatever comes out, somebody needs to validate it, and it will take a lot of time and a lot of effort. But what comes out is definitely worth it because this is something you can immediately use.
Okay.
So it's for purposes. Yeah, please.
Sorry, go ahead.
So it's for purposes where it's a little bit complex. It's like a picture or voice or text or something more complex that you need to understand with a computer. Then deep learning might be the solution. But since it's very popular now, people think that it's always the solution. It is not. So if you have a problem, you can't say that deep learning is the silver bullet for that. It's not the solution for everything. But for some use cases, it's a very good solution.
And is tied together with big data?
Yes, also that. Yes. So it's one kind of machine learning. And big data comes to picture because we need to have data to be able to do machine learning. There's an exception. Reinforcement learning can build its own data. So for that, we don't need. But most of the machine learning, we need to have data, and usually a lot of data. And one of the reasons that deep learning didn't actually strike through the time that people already invented convolutional networks and so on, was that we didn't have enough data. Now, because of big data, we have enough data and we have pre-trained models or data sets that we can use to train faster. So a lot of things has improved during the past years, let's say since maybe 2012 or something like that. So it's quite recent thing. But already the things we can do with deep learning now, already in production, is a lot. So this is a growing area.
Okay, and how does it work? And without giving you a whole presentation, just give us
Okay, I give you a simple example. So if we do image recognition, so I have pictures of women and men, and I give these pictures to computer to learn which one it is. So of course, in the data set, I have to know which one it is. So when I'm training, I have to know which one. So I give a lot of data of big pictures of people, they are men or they are women, and I tell the computer already which one it is. And it's trying to find a way to realize which one is which. So in the end, the outcome is that you will give a picture and it will tell you, is it a man or a woman? Or just recently, somebody built a very nice system where you can figure out the age of a person. So you just give a picture and the system tells you what is the age of this person. So it's quite interesting. What's happening in the middle is a thing called convolutional network. And that's something that kind of puts the data in places. Now, I don't tell the whole story. You have to wait for Dev.next to hear this. But that's the thing that happens.
But in brief, what is a convolutional network?
Okay, so if we talk about pictures again, it could be also text or voice or something like that. So it could be we are talking and it's actually translating that to text, and this text is given to another machine learning, whatever thing it is that you want to do with that. So it can do that kind of conversions. But if we talk about the picture, so first it takes shapes and so on from the picture, so to recognize what is in the picture. So it finds my eyes, the face, the nose, the mouth, all kind of things, and it processes all this information through the convolutional network to find out that it's actually a human face and actually a female face. So it's somehow it's cutting the picture and then putting it back together in the short way to explain. It's all about matrices. So this is matrix calculation. Everything that happens here is about matrices. So if you were studying that in school, you know exactly what's happening. You are just adding them together, you're multiplying them, and so on and so on. That's what's happening.
It reminds me back of my college. Matrices, the last time I remember hearing that was during my college days.
But actually, now that I studied again, it's quite simple. It is not complicated at all. But that's something you should understand if you want to understand what deep learning is doing, because it's about matrices. The whole thing is about that.
Okay, all right then. Well, it sounds like a really exciting presentation, and
I hope so.
we get to check it out later on in this year. Heli, as I mentioned up front, it's always a pleasure speaking with you. Thank you so much for giving us your time. Thank you.
Thank you.